Hi guys, welcome to another video of Physics 2. This is the second problem of friction force, okay? So in this case, we got an horizontal surface in which there is a block of 11 kilograms. So this block is being pulled by a force of 70 newtons. This force has an angle with the horizontal line of 40 degrees. Also, well, the direction of the motion is to the right. The acceleration of the block is 1.2 meters per second square, and we have kinetic friction force, and this is because the block is already moving. And the question is the coefficient, well, find the coefficient of the kinetic friction force. Okay, so remember that the first thing that we need to do in this type of problems is to draw the free body diagram. So let's draw it over here. FBD, free body diagram, and the free body diagram is a Cartesian plane. It doesn't matter the dimensions of the Cartesian plane because I'm not going to write numbers on it, just the forces that interact with the body. So this is X, this is Y. In the center, I'm going to draw the particle that is going to represent the block. I don't care about the dimensions, just the mass. Okay, so let's draw all the forces that interact with the body. So the first force that is going to be drawn is not over here, it's not mentioned, but we know that it's always there, is the weight. And the weight always goes down or points to the center of the earth. That's the weight. And then we got the force, that force of 70 newtons. But remember that we don't want that vector. Okay, we want the rectangular components. Okay, because I need the forces to be over the axis. This could be X or Y. So in this case, this force is not over the axis, so I need the rectangular components. And remember, every vector has two rectangular components. Okay, so we're gonna have fx that points to the right because the vector goes to the right. This is fx, and this is fy. Okay, goes up. Of course, we got the kinetic friction force that the friction force goes against the motion. So in this case, points to the left, just like this. This is the kinetic friction force. And the object is over a surface. So they are in touch. So every time that happens, I'm going to have normal force, and the normal force is going to be perpendicular to the surface and opposite to the weight. So the normal force points up, just like this. And I'm gonna draw it with the green color, and that's it. That is my normal force, and this is the free body diagram. And I believe that I got all the forces: Fx, Fy, the weight, the friction force, and the normal force. Now let's continue. Let's make the analysis in each dimension. First, I'm going to do it in the x-axis. Okay, x-axis. And the analysis begins like this. The sum of all forces in x equals. Okay, so if you see, the block is going to move over the x-axis and it's going to have acceleration. In this case, is 1.2 meters per second square. So the sum of all forces in x is going to be equal to mass times acceleration. Okay, so what forces do I have on x? I got Fx that goes to the right and friction force that goes to the left. Everything that goes to the right is positive, everything that goes to the left is negative. So in this case, Fx minus kinetic friction force equals mass times acceleration. Okay, so I need to find the coefficient. Remember that the friction force has a formula, and that formula is this one. Kinetic friction force equals the coefficient of the kinetic friction force times the normal force. Okay, so the kinetic is inside of the formula of the kinetic friction force, so I need to isolate friction force. Okay, so minus friction force equals mass times acceleration minus Fx. I'm going to remove this negative sign of the friction force by changing all the signs of all the terms in my equations, both sides, left and right. So kinetic friction force equals Fx minus mass times acceleration. And then I'm going to substitute the value of the kinetic friction force. Okay, kinetic friction force equals the coefficient times the normal force equals Fx minus mass times acceleration. And I'm going to, this normal force is multiplying, so I'm going to move it to the other side, dividing. So coefficient of the kinetic friction force equals Fx minus mass times acceleration over the normal force. Now, can I solve this equation? Well, I know the value of Fx. Well, I don't know it yet, but I can find it. I have the mass of the block, I got the acceleration, but I don't know the normal force. So in order to know the normal force, I need to make the analysis in the other axis. In this case is the y-axis. So let's do it. Okay, so I'm gonna do it over here. So y-axis. So let's begin. The sum of all forces in y equals how much? Well, in this case, the object is not going to move on the y-axis, so it's going to be equal to 0. So what are the forces that I have in y-axis? I got Fy, normal force, both point up, so they're going to be positive, and the weight goes down, it's going to be negative. So I'm going to have normal force plus Fy minus weight equals 0. I'm going to isolate the normal force because that's the one that I need. If you see over here, that's the one that I need. Okay, so normal force equals, equals the weight minus Fy. Okay, I just move the weight to the other side with opposite sign and also Fy with the opposite sign. Okay, so that's it. Then what I'm going to do, I'm going to substitute the value of the normal force over here. So I'm going to do it in this part over here. So let's continue. The kinetic coefficient of the friction force equals Fx minus mass times acceleration over normal force. So normal force is weight minus Fy. Okay, so let's continue with this equation. Okay, so this will be Fx. Fx, if you remember, is F times the cosine of the angle minus the mass times acceleration over the weight is mass times gravity minus the force times the sine of the angle. Okay, so this is the equation that I'm going to use in order to find the kinetic coefficient of the friction force. So let's do it in the calculator. Okay, so fraction, the force is 70 times the cosine of 40 minus parenthesis mass, the mass is 11 kilograms times the acceleration, that is 1.2 meters per second square, over parenthesis the mass 11 times the gravity. Remember that in this case gravity is going to be positive, 9.8 meters per second square, minus the force, that is 70 newtons, times the sine of the angle, that is 40 degrees. Okay, so I'm gonna press the equal button, and that is the kinetic coefficient of the friction force. Remember that this value over here does not have units, so the coefficient equals 0.6436. Okay, so this number does not have units, and it's a number between 0 and 1. 0 means that there is no friction between the surfaces, and 1 means that it's very difficult to move that block over that surface. It's a very rough surface. Okay, so in this case it's 0.6436, and this is the answer of this problem. What you can do, for example, another thing that you can do is that you can also find the value of the friction force, and you can do it with this equation over here, but of course only if you want. Okay, so this was the second problem about the friction force. I hope I made myself clear, and I hope I see you guys in the next video. So bye bye, take care.